My name is Darragh. This is kind of related to some work I was doing for the HP Cloud Services, which is actually hpcloud.com. Anyone's actually used the HP public cloud. And one of the problems we faced was we needed to actually be able to sync with all the OpenStack projects on pretty much about a 4 to 5 hour basis and be able to port all of our changes to replay them on top of that multiple times a day. So we were using Gerrit, we're using the entire same tool chain as OpenStack, and this is a quick, brief introduction. Even though it's a lot of slides, I'm going to breeze through really quickly. There's no demo. If somebody wants to see the code in action, come and talk to me afterwards. And hopefully I can get through this like in less than 10 minutes. Okay, so basic problem, anyone who's deploying software out there, you take something from Upstream and you want to deploy it on the system and it doesn't work. Solution, you're going to patch it. Ideally, you want Upstream to take that patch and you're going to take it when they have it ready. The main problem is lead time, and that's like 2 weeks, good time, maybe a couple of months, like if they're really slow. We needed it in a matter of hours because if there was a bug, our production was going down and we needed to deploy it in about an hour to 2 hours. So basically the reality is we need to carry local changes and we needed a really simple way to be able to replay those every time we sync. This is our tool chain. This is code review. We've got Git. See if I can get the laser. We're basically using Git at the top there. Gerrit was our code review, go into Jenkins, test everything, review everything, and finally check everything when review passed and make sure it's all built. So as soon as it came out the other end of that was going to QA systems. And then once QA said, we're happy with that, it was hitting production. And our goal was to actually ensure that, that up here, the code coming in from Upstream was ideally less than 24 hours old. And that might scare a few people because that's pretty insane to like kind of lead time. But before I left, I know the guys working on the Nova project actually only were taking it in less than 24 hours from Upstream and testing it and looking to deploy it to all of their R&D systems. So I mean, we really were doing it really fast. What do we really want? Well, the worst thing possibly, we did not want to have to do code review of diffs. And I say diffs, I mean diffs of diffs, which is exactly what you see in most packaging tools, where they're using patch queues and series files, and when you actually can roll back, it's this like, horrendous looking thing that you have to work out what it actually is. You can't code review that. You have to do something with it before you code review it. We wanted the developers to be able to do something with the project before they cracked it, so no patch series files, no patch queues. And we want to be able to port all the changes without the developers needing to do anything complex in Git. So if we need to script something complex in Git and hide it, that's fine. But day-to-day, developers, the feature branch checked out, there is no way we want them to do something, use the kind of the really interesting features of Git rebase to totally port branches from one commit to another. That's really hairy stuff, and it's fine if you know what you're doing, but 90% of the developers we just said, like, we don't want to worry about that, we'll hide it from you. And kind of the really important things were that we really want to be able to re-review everything that we made on or change on top of the project, if necessary, and retest everything at the same time, each individual change, and see if anything broke in the individual change. So if we 20 changes on top of a project, when we pulled in the latest from Upstream, we wanted to test 20 runs and check that each one worked perfectly as it did before, so that if any of them broke, people didn't have to go and hunt through the patch to see what broke it. And basically work with the tool chain and some fancy features to drop and changes that appear at Upstream as quickly as possible. So that's it, the app series. That was out the window. We looked at trying to merge Upstream into parent, which is kind of a traditional approach, or we kind of said, well, maybe Git could do some of the work for us. There are a lot of tools in this area that can help if you kind of are working with this sort of stuff and you want to be able to assume upstream projects. The main problem is that most of them are these first two, most of their information, they kind of cache it in your local working area, so you can't share the information as to how you need to, which branches you need to move forward or what changes have to be rebased. The next two are really just kind of series files type ones that, again, you didn't want to touch. But if you're working with Debian packages or Red Hat packages, they're actually quite handy. And the last two we just turned out to be too Debian and Ubuntu centric, in that we couldn't actually make them work the way we wanted to. But they're very close, and if we really spent some time, we probably could have made that last one, Git DPM, work reasonably well with Gerrit. But we decided to go a different direction. Main problem with merging, you need an Uber integrator. Is because you get a huge conflict when there's been a lot of changes, and one person has to know most of the code base in order to be able to fix it all. So that was probably, those two reasons were the main reasons we just said, no, that's not going to happen. There's a few other small reasons. You can end up with some very interesting behavior about having changes saved in merges and not being able to backport them sensibly. So basically we discarded that as not being sensible. So we looked elsewhere and we said, could rebase help us? Git has this ability to take a whole list of changes and replay them elsewhere. It just has that really small problem about the fact that we rebase a publicly pushed branch that it completely messes up everybody else's downstream of you. So we said, we'll look at it and see if we can find a way around that. Main reasons we wanted this because it actually works really nicely. If you want to re-review everything, you've got all your changes that were there, replayed on top. You can actually track the history of your changes, and it makes it really easy to port changes then between branches. So if you've got something in production, you've got a change that's just come through and landed on your master branch, really easy to just port it across as a hotfix. You don't have to go hunting through a couple of merges to see how many other things do I actually need to make that change work. So you can kind of trick Git a little bit. You can do a kind of merge strategy on top of the rebase, full Git and help it make all your developers' lives really easy. It has an hours strategy. So you can essentially use that to say, well, whatever's on this branch, whatever's on the branch I'm on now, accept that as the golden fruit, merge in the old ones so that you know historically how to rebase and branch against it onto this new stuff, but ignore everything that's on the old one, please. That meant that anytime somebody did a git pull, it basically hit the whole problem of the complex rebase. Git would actually be able to rebase a local feature branch against what is essentially a rebase master. So this is basically a diagram. So each time we were basically taking from upstream, we created another branch of it. We would rebase the changes. Rebase is really just cherry pick on steroids. It's just doing it on the branch level. So essentially, it's just cherry picking. Usually, it's probably about 20 to 25 changes, and then we would do a merge to tell sort of Git anyone who had a feature branch off here at this point. Git would actually know how to walk that to rebase their feature branch locally. So, one problem with it, slightly confusing history, you could invert an hour strategy really easily with Git because there's no there strategy, just because the developer said, no, we don't need it. But you can just invert it very quickly. The code I have doesn't actually use that because it's cleaner to use some of the cloning commands underneath that. But that's essentially, if you ever need to discard what's on your current branch and accept what's on another branch, you can use those commands in this way. The commands that I had actually worked out the history of all the changes that need to be rebased. They're a bit more complex. We basically use git red list and the options are called ancestry path. And if someone's interested in that sort of stuff, I will show you on my laptop and the actual code working. But it gets a little bit complex in trying to explain how that stuff works. So what that effectively does is it basically tells it that the branch is ended there. Ignore all the history behind here and accept whatever came from the import as the golden stuff going forward. And as far as everybody's concerned, it can kind of understand, oh, this is the original master, this is the new master, everything makes sense. And when you're dealing with a lot of people that don't understand Git under the hood, that's golden. Why didn't we do this? It looks easier, just like do the merge, replay all the changes on top. Gerrit hates that. It has this idea that you must have every change that you send up to it to review must be unique. But the way it identifies stuff as being unique is that it has to be unique project, branch, and a change ID. The change ID is a little kind of SHA-1 equivalent thing put in the very end of the commit message.
So why did you just fix Gerrit?
Because that meant that we'd lose the ability to kind of ask Gerrit, this change at the top, I want to see every previous revision that we had each time that we rebased and brought that forward. We could have just pushed it. You can't just ask Gerrit, like, just accept this, I don't want to review it. But if you want to be able to re-review it in certain cases where stuff breaks or change needs to be reworked and you want somebody else to look at your work, it's handy to be able to see the previous one, see the new one, and see the history between them and move forward and know that you can actually trace that back.
Easy this off, so.
Yeah. I'll stick with Gerrit and Git. So Gerrit uses a change ID insert at the end of the commit message, and that has to be unique, that combination. For reviews, you can ignore reviews. You can push right past Gerrit. It won't stop you provided you have permissions in the project. The other big problem is that it essentially regresses the main run first in order before we can move forward. And if you want to follow the idea that your main line should be releasable, the only time that you should change it is when you actually have something that you know is going to be equal to it or better. So that plays nice with Gerrit. In order to make it easy to import, we just have a branch, push that up, and then at the end we have an automated job that says, right, you know all the changes we imported, close it off. So it's written in Python. Not open source. That's my fault because I haven't talked to my previous employer and persuaded them to let me upstream it. They let me do it most other code. So I can show people who are interested in it, but I cannot give you a copy of it. Pretty nifty. It's not particularly advanced. It's been done before in other tools. It's just it works nice with Gerrit. I was going to do a demo. Unfortunately, my laptop doesn't work with HDMI, so that's with that. It is, if you're in that area and you're looking at trying to solve that problem, it's worth looking at some of the other tools because this specific problem was more our problem rather than necessarily a generic one. If you have a lead time of like 1 to 2 months between you needing to actually take the latest, like you've got tracking a slow development project, you don't need this. You can branch off and just kind of put your changes on a separate branch, and it's relatively easy for your developers to know when they're going to have to work against another branch. When it's changing every single day, and there's 50 commits landing on the project upstream, and you're resyncing and rebasing on that every single day, that's too much, it's too often, and that's what you need. It's just frequency of change. So, as I said, I hope it gets back. Any questions? And that was definitely the
A very quick one. You mentioned Quilt and you mentioned the annoyance of package managers and the diff.
Yeah.
You can throw that out the window because at least Debian, the package manager knows how to talk Git natively. And that includes all of the stuff.
No, I don't believe it quite knows how to, but there's enough tools written around it that it actually is able to use it now. So the Git build package is pretty much the most common one to use with Debian packages. But I think it's actually Git DBM is the actual Debian package maintainer project for working on Git. It understands it, but it doesn't play nice with Gerrit.
Oh, okay.
Yeah.
But I mean, the package has a format. You can say, I'm working in Git format. And then it just straight away shows all the
Yeah, there's a difference there. That's the source format, and that ignores a patch queue. So yes, but we're not using patch queues in packaging, but if you still need to maintain your changes on top of your actual original upstream
Well,
project.
the nodes problem doesn't go away. It all commits to Git there. I mean, the entire nodes problem is now.
Yeah, but it's up to you to manage your code in Git. Then it'll just take it out of it and build it for you. Anything else?
Yeah, exactly.
Yeah, so if anyone's interested afterwards, I can boot up my laptop and show you the actual Python code in its ugly glory. It's not too and everything's particularly nice. Alright, thank you, Darragh.